Dr. Roningland here with Module 10, Lecture 2, Incremental Analysis. And again, another way to look at money. Well, kind of the same thing, but we're going to look at another way to compare, in this case, primarily mutually exclusive projects. So let's look at that. We got two alternatives that are mutually exclusive. You can only do one or the other. And you got to make a decision upon which of the two to do. Now, here's the situations that are going to occur. So let's look at this project. You sink $1,000 in year 0 and you get back $2,000 in year 1. Or you sink $5,000 in year 0 and you get back $7,000. So the rate of return on project 1 is going to be greater than the rate of return on project 2. It's 100% versus 40%. Pretty easy to calculate those rates of return with just 1 year. However, the present worth of each project goes in a different direction. Well, that's a problem. And the reason that that problem is that IRR doesn't take into account, your rates of return don't take into account the magnitudes of the projects. So let's first kind of look at some just numbers here. So let's say we got two employees, Bill and Nancy. Bill gets a 10% raise, Nancy gets a 5% raise. Who actually got the better raise? Well, it depends. You say a 10% raise on 50,000 is less than a 5% raise on 200,000. So truly, in the end, Nancy actually got the better raise, even though she had the percentage change was less. So when we're looking at projects, looking at IRR, it doesn't give you the whole picture. So just looking at projects and saying which one gives you the highest rate of return is not going to be the route that you're going to take. All right, so what can we do here? We got other ways to do this. One of the approaches that you can take is the incremental investment approach. So let's just say we got an investment pool of $5,000 with a MAR of 10%. So basically the funds in the pool can earn 10%. And we got two potential investments that we can make right this minute. Now, look at investment 1. You top in $1,000, you get back $2,000. That looks pretty good. Look at investment 2. You got to sink your entire investment pool back, but in year 1, you get a return of $7,000. Well, which one of those two is the best one? Well, if you look at just the rate of return on the two, IRR, you're going to think, well, that 100% is looking pretty good for project 1. Project 2 has only got a 40% rate of return. Not bad, but again, not 100%. The present worth of the projects at 818 versus 1364, well, that looks a little bit more skewed towards project 2. Well, I want to look at this. I want to look at this a different way here. I want to come back and I want to look at this and say, what if we just take project 1 in the pool and look at the total? So I invest $1,000, get back 2,000. I keep the pool and I'm making interest off the pool. Let's say we're making that interest back at the MAR. So in the end, in year 2, you got $6,400 in investment project 1, which is a rate of return of 28%. If you look at project 2, okay, nothing's left in the pool, but in year 2, you've got to return $7,000, and the if you're looking at, and again, this total is, oops, I put that total there, 7,000, not 6,400. Hang on, this is 7,000. Sorry, that's my typo. There we go. Now it's fixed. You know, you got a different. The present worth actually comes back to the same, and 40%. What's a way we can look at it besides doing that? Well, let's look at incremental investment. If I subtract the original amount of money put in, so I had 5,000 and 1,000, so the difference is 4,000. And I look at the difference in the money made, 7,000 versus 2,000. That's 5,000 total. Okay, you can see that's where these numbers came from. I had 5,000 to sink, 1,000 to sink, so there's going to be 4,000 sunk into the initial investment. And that's an incremental. That's looking at them, side by side. 5,000, the 7 and the 2, 5,000 back in return. And I let's then say, well, look at this. I've got back 25%. So is 2 looking at a better investment than 1? I can't do them both. So you do make additional money, but more important, you earn an equivalent rate of 25%, which is more than the MAR, which is what you want to see. So when you're looking at an incremental investment, by subtracting the 2 off of each other and looking to see if it's above the MAR, you can say, hey, this is actually a better investment. So what does this mean? Let's look at this in a couple other cases. You're looking at the cash flow differences between the 2 investments. By taking those 2 cash flow differences, and it doesn't matter. In this case, I had really simple. I only had an in and an out, single one of each. Okay, but we're only going to accept this investment if the difference is greater than the MAR, and if it is, then you've got a decent investment. You can compare the 2 that way. Go back and say this again. I took the 2 investments and I subtracted the cash flow on the annual basis. Every year I just subtracted the cash flows between the 2. And I looked to see if that rate of return was greater than the MAR, and if it is, I'd say that is a good investment. Now, another example. Okay, and in this case, I actually show that you can actually plot the present worth versus the interest rates, which is kind of interesting that you can do that. But really, same concept. You got 3 grand, 12 grand. I've got 3 years now. Okay, MAR 10%. I change that MAR. Realize that those other numbers are going to actually present worth are going to change too. But I look at those and I say, you know what? Here's the difference in the cash flows. The 9 grand is the difference between the 12 and the 3. 2850 is the difference between these 2. And I calculate the rate of return on the difference, and I compare that to the MAR, and it looks good. It's greater than the MAR, so therefore it is a good investment. That's it. That's the procedure. What happens if you got 3? Well, pretty simple. If you got 3 of them, just compare one to the other. In this case, I can compare D1 and D2. Whichever one of those 2 is the best investment there. Okay, in this case, I'll go D1 minus D2. Okay, look at the comparison between the 2 and see if that comes out to be greater than the MAR that we're looking at. If it is, we're going to say, you know what? We're going to select that one. Same thing we just did, just getting rid of 3. Since D1 is the best of those 2 investments, we now can compare it to the other investment, D1 and D3. So in this case, I'm going to go D3 minus D1, greater minus less. And in this case, the rate of return is actually comes out less than, when I do the comparison between the 2, comes out to be less than the MAR. And in that case, D1 ends up being the best of the 3 investments. See that? I compared D1 and D2 by taking the cash flows for each year, getting the rate of return, and then comparing that against the MAR, and then picking out, okay, is this better? And if D1 had not been, it would have been D2. We would have just gone with D2, and then we would compare D2 with D3. Okay, trying to make this as simple as possible. It really isn't that hard. All right, suppose the project is a cost-only project. Well, the concept isn't really that much difference. So you're saying, okay, I got this option versus that option. What do? Well, again, you can say, let's just take the incremental cash flows between the 2 of them, separate them against each other, okay? one versus the other. The other one actually has a salvage cost that's associated with that. Okay, so now I've got an incremental cash flow. That's the incremental, which is the difference between the two. And I can calculate the present worth of those cash flows. Okay, from that, I can get the I that goes with that specific present worth, because all you do when you're doing rate of return is set that present worth to 0 and calculate the I, the interest rate that goes with it, and I compare it against the MAR again. Okay, and if it's lower for the one that you've done, on the left-hand side of the subtraction, you pick the one on the right-hand side of the subtraction, which is what we do in this case. Had it been greater than the MAR, we would have gone with the FMS. We go over that again. We subtract the cash flows against each other. In this case, we did FMS minus CMS. We calculated the interest rate based on the present worth set to 0. That is exactly from earlier when we said you want to get the rate of return. You set the present worth of the cash flows to 0 and calculate the interest rate. That's just solving for I. Solving for I. And when you solve for I, you can compare it against the MAR and determine which of those you want is the better one. So you got a few things that you actually got new terms, but we really haven't done. All we're doing is looking at the same thing in different ways. And so far in our analysis, all we've done is we have looked at present worth, compared them, looked at annual equivalences and compared them, and looked at rate of return, which is an interest rate, and compared them. Okay. Now, what we've added to this is the comparison between mutually exclusive projects, where we subtract the cash flows against each other and compare them against the break-even interest against the R, or the MAR. Let's call it the MAR. So these are just a few of the internal rate of return. Okay, we're looking at projects that are internally invested. Okay, not borrowed. Okay, now there is one thing that is important here: simple versus non-simple investments, because mathematically a simple investment will only give you one rate of return. Whereas non-simple, because you're looking at the concept that it can be quadratic, can actually have multiple. PW equal to 0, present worth equal to 0, can be solved with multiple interest rates. Okay, doesn't mean it will, but it can, and that's important. So, simple investment, easy. IRR greater than, less than, or equal to the MAR, you go with it. However, if it's not simple, you've actually got multiple ways to look at that. And when looking at an alternative project with IRR analysis, what I just did, the incremental investment, cash flows in each investment compared against each other to then calculate the rate of return, which may be taking it to present worth and then calculating the rate of return, solving for I, and comparing it against the MAR. That is how you do it. Hoping you got this. It's not that hard, but it does build on a lot of principles of things that we have done. So what do you need to know how to do here? Well, one is you need to know how to convert a bunch of line items, money, cash flows to a present worth. You need to know how to, with that present worth and the number of years, solve for I, because that's the rate of return, and that's the most common. You also, from the previous chapter, could convert that to annualized equivalence, which is basically converting P, present value, to A, annualized value. When dealing with mutually exclusive investments, where you've got to compare an investment against another to know which one's the best, that incremental investment technique can be really, really handy. In the end, you're going to solve for I, you're going to get that rate of return, and you're going to compare it against the MAR. There you go. That's it. Have fun. Go to it. Do well.